channel. So in today's video I will be starting analog electronics, and the first topic in analog electronics is BJT, bipolar junction transistor. So since this is all about analog electronics, so I will be starting my first topic, which is region of operation. So basically what happened in analog circuits, BJT can be operated in active mode, saturation mode, cutoff mode, and inverse active mode. So practically it gets operated in active, saturation, and cutoff. But saturation and cutoff mode we use in digital circuits because where we want to make our BJT to work as a switch. But for amplifier operation, like in analog circuits, we require to make BJT to work in active region so that amplifier operation can be performed very easily. So guys, there are 2 or 3 methods to find the region of operation, and I will be discussing all the 2-3 methods, and I hope कि आपको ये 2 से 3 methods अच्छे से समझ आने के बाद then आपको कोई भी circuit मिल जाए, आप easily उसका region of operation find out कर लोगे. Okay, so let's start with method 1. The step 1 says assume that BJT is operating in saturation region. Okay, आपके पास कोई भी circuit provided है, you have to assume that कि BJT saturation mode में work कर रहा है, right? उसके बाद अगर BJT saturation mode में work कर रहा है, then we are having some standard values of VCE and VBE. The values of VCE saturation is 0.2 volts for silicon and 0.1 volt for germanium, and the value of VBE saturation is 0.8 volts for silicon and 0.3 volts for germanium, and these values are of NPN transistor. For PNP transistor, just take the negative values for this. Okay, now coming back to step 2. Step 2 says calculate IB, which is base current, and IC. IC is basically the saturation current because we are assuming that transistor is in saturation. Independently, without using the relation IC is equals to beta IB relation. इस relation को use नहीं करना है, हमें VCE और VBE की values को use करके IB और IC की value find out करनी है. And this IC is basically the IC saturation. Okay, guys, please note down these steps very carefully because these steps really work in your numericals. Okay. So step 3 says calculate the minimum base current needed to operate BJT in saturation region. So we have to find the minimum base current, and minimum base current we can find with the help of this formula, which is IB minimum is equals to IC saturation by beta. IC saturation we get from this IC value. Okay, so that's how we find IB minimum. So fourth and final step says compare IB and IB minimum. IB we have calculated in the second step by using the values of VBE, and IB minimum we have calculated by using this formula, which is IC saturation by beta. So if IB is greater than equals to IB minimum, then our BJT works in saturation region. If IB is less than IB minimum, BJT works in active region, and if IB is found to be negative, then BJT operates in cutoff region. Okay, that's simple it is. Now let's discuss one numerical. So this is the question, guys. Find region of operation, and beta is given in the question, which is 100. VBE saturation is 0.8 and VCE saturation is 0.2 volts, which is also given in the question. And this is the circuit, guys. So basically we have to follow some steps and apply some basic networks like KCL and KVL in the loops to get our result. Okay, so let's start from the basic. Okay, so basically क्या करना होता है हमें, सबसे पहले ये जो voltages हैं इन्हें आप batteries से reduce कर दीजिए if you are not comfortable of using these values. Okay, so I am replacing this with a battery and it is also grounded. Okay, and this this is also a DC voltage, so I am replacing this with a battery. That's it. Okay, 10 volts. After that, this is 3K guys, and this is 50K. Okay, after that, mark the voltages. This is VBE and this is VCE. Okay, if you don't mark the voltages, then sometimes you get forget while doing the numericals. So it's very important कि आप voltages को mark कर लीजिए. Next thing is that we only have to apply 2 KVL loops to get our result. That's simple it is. Okay, so just applying KVL in this loop. This is loop 1. Okay, applying KVL in this loop. So see how I am applying. -5 plus 50 IB. Okay, IB. This is IE. Okay, 50 IB plus में VBE, this voltage, plus में 2 IE is equals to 0. So the thing is that in the first step, we have to use these values, VB saturation, but we don't have to use beta. Okay, so just taking IE is equals to IB plus IC, which we know very well, this relation. So replacing IE with this, plus में 2 IB plus IC is equals to 5 VB 0.8, then 50 IB plus 2 IB plus 2 IC, and it is equal to 4.2. So the equation becomes 52 IB plus में 2 IC is equals to 4.2, and this is equation 1. Okay, now loop 2. So this is loop 2 guys, from ground to ground. Okay, ground से लेके ground तक loop बन चुका है. So this is loop 2. We have to apply KVL in loop 2. See, from here I am starting and up to here. Okay, so it will be KVL in loop 2. It is -10 plus में 3 IC plus में VCE plus में 2 IE is equals to 0. Okay, again replacing IE with IB plus IC. So it will become 3 IC plus में 2 IB plus IC, shifting 10 there, 10 minus, the value of VC saturation is 0.2 volts, 0.2. So this will become 3 IC plus में 2 IB plus में 2 IC is equals to 9.8. Okay, and this will become 2 IB plus में 5 IC is equals to 9.8. This is equation 1 and 2. 1 and 2. On solving these two equations, I will be having IB is equals to 5.46 microampere and IC is equals to 1.95 milliampere. Okay, and this IC is basically IC saturation because we are assuming the transistor to be in saturation. Okay, so our third step is calculate IB minimum. Okay, so I am calculating IB minimum. IB minimum equals to IC saturation by beta, and it will become 1.95 by 100. So it becomes 19.5 microampere. Okay, be careful with the units, guys, always. So step 4 is of comparing this IB minimum with this IB. Okay, so here while comparing, I'm having IB is less than IB minimum. Okay, so if IB is less than IB minimum, then our BJT is an active region. So that's how you can solve the problem.